This is a solution to problem 73 from section 3.1. We're asked to find two positive real numbers whose product is a maximum. The sum of the first and twice the second is 24. So first we're going to define our variables. So I'm going to say let m equal the first positive real number and let n equal the second positive real number. If you use x and y, it starts to get confusing. So m and n seem to work better. And then we're given some information about the relationship between m and n. We're told that the sum of the first, so that would be m plus twice the second, 2n is equal to 24. And we're supposed to find these values so that the product is a maximum. So the product, that function, is going to be equal to m times n. But we only know how to find the maximum if we have a function in one variable. So we want to write this in terms of one of the two variables. We already have a relationship between them. We know that m plus 2n equals 24. I'm going to isolate m here. So m is equal to 24 minus 2n. And then I can substitute this expression in for n in my product function. So I'm going to have the product now as a function of only the variable n is going to be 24 minus 2n, that's what m was, times n. Now we can find the maximum. We can find where the maximum occurs. This is a quadratic function. There's more than one way to find the maximum. I'm going to go ahead and write this in general form. So I'm going to distribute the n. So we'll have negative 2n squared plus 24n is our function. And when we have general form, we know that the maximum occurs at the vertex, and the n value of the vertex, normally it's the x value of the vertex for this function, will be at negative b over 2a. So the opposite of b is 24 over 2 times a, which is negative 2. So we have negative 24 over negative 4, which is 6. So n is equal to 6. That's the value of n that leads to the maximum product. To find m, we can use this relationship that we have between m and n. So we're going to substitute into this expression. M is equal to 24 minus 2n. But now we know that n is 6. So it's 24 minus 2 times 6, which is 24 minus 12, which is equal to 12. So the two numbers are 6 and 12. That's our solution. And this problem didn't request us to find the maximum product. But if it did, the maximum product would be the y value of the vertex. So we could substitute in n is 6 into p of n, or in this case, we could simply multiply the two numbers, 6 times 12, to get 72.